Hello and welcome back. Just have returned from about a month away doing some field service work in Oregon and turned on the power to the ham shack. While I was away, I turned off all the breakers so that everything in here is completely shut down. Everything was normal, everything was fine. Went out, did a little grocery shopping, came back home and found this. All the lights on this amplifier, or the meter lights, both the lights and the light on the tuner, are partially lit, dimly lit. Now, the amplifier is off, and the 12 volts for this lamp is supplied by the 12 volt output here. This used to be a standard AL-800 amplifier. It's now my 6 meter amp, converted it over, and I've got about 900 watts on 6 meters. But that's besides the point here. What's going on? Now, if I turn on the switch for the amplifier, you'll see this comes up to normal brilliance, this will come to normal brilliance, and this will go out, which is normal, because this won't turn on normally until the tube has had enough time to warm up. There's a timer circuit, so let's do that. And as you can see, we now have normal operating voltage. But as soon as I turn off the power switch, and you can see this light's out and it's slowly coming back on, there it is, all the panel lights are lit. Now the switch is off, and I can also hear the fan running in the background. It's running very slowly, but it's actually running inside the amplifier. Now the whine you hear is probably the UPS on my computer that the camera's probably picking up. I don't know if you can hear the fan in the amplifier. During this time of year when a lot of people are running air conditioning, the voltage drops once in a while and the UPS kicks on. And it has to run the fan until everything cools down. I just kind of ignore it. At any rate, that's all besides the point. What is going on here? Let's take a look at the schematic and see if we can figure this out. Okay, so a quick look at the schematic reveals this, and this is a simplified version of the schematic. It's a whole lot easier to follow than the one in the book. I'm running the amplifier on 220 volts. It appears, using the swag method, that the lamps are running at about half or slightly less than half brilliance, so I'm guessing they're running on 6 volts or less. And that would almost make sense if we had a path from one of these legs to ground, because it would be 110 volts from here to here and 110 volts from here to here, 220 volts across the unit. We come in from the plug, there's 2 fuses, we have a couple of bypass capacitors. Now at first glance I quickly said, the bypass cap is gone, but there's no path to ground because both of these switches are open. This is the safety switch on the cover. This is the main power switch. If this capacitor was leaking to ground, there's no path for the current through the primary. If this capacitor is leaking to ground, again, because the switches are open, there's no path through the primary. Looking at the next page of the schematic, I find that on the power supply board, there's this arrangement. 2 capacitors with a center tap to ground. Aha! I suspect that this capacitor right here is leaking, and leaking fairly heavily, because there's not much else in here that are going to supply a path to ground. The voltage is going to come in this 110 volt leg through the primary of the transformer through this capacitor to ground, and in my way of thinking, that's going to give me roughly half the secondary voltage. Now, these are just drawn in, but one of these is going to be a winding for the 12 volt power supply. If it's running on 220 volts, the transformer's tapped for 220, we should be getting 12 volts out. Likewise, if one leg is open and we're referencing to ground, we're going to have 110 volts if the circuit's coming through the primary and here to ground using one leg. And that would account for the roughly 6 volts on the panel lamps being on and the fact that the fan's running. What is curious is this switch is always closed when the cover's on the unit. When you close the main power switch, it doesn't blow either fuse. So the leak has got to be bad enough to pull enough current to light the lamps up and slowly run the fan, but evidently isn't quite bad enough yet to blow the fuses, or a fuse. It's fused on both legs. These are 12 amp fuses at 220 volts. They'd be 20 amp fuses roughly at 115. So what we're going to do is move things around, pop the cover off of this, and see what we can find. And remember, inside of this, the voltages are highly, highly lethal. You've got a couple of thousand volts, actually close to 3,000 volts on the high voltage winding, and even under this configuration, you're still going to have 1,500 volts of AC on that secondary. So let's pull the covers off and see what we can find and see if I know what I'm talking about. All right, we have the beast on the bench. Now either I'm getting older or this thing is getting heavier. I don't remember it being this heavy. I am going to go with it's getting heavier, probably due to all the equipment stacked on top of it or compressing the atoms and making it more dense. And before anybody writes in, I know. Okay. Before I even take the cover off, I'm going to make a real simple test here. We'll move the camera up. We've got the plug. And let's see what we've got. Get out my trusty old triplet here. And this is running about 30 volts on the 100K scale. It uses 3 9-volt batteries in series. Let's see what we've got. Now, bearing in mind, have we got the meter in the view here? Yeah, move it up a little bit. It's hard to tell when I'm standing here trying to do everything. Okay, I'm going to put the ohm meter from ground, and the switch is off, so there should be nothing on one of these legs. Okay, let's turn the switch on. Look at that. That shouldn't be there. Let's go to the other leg again. The switch is off. Oh dear, that looks pretty much like a dead short. Let's go to a lower range. Let's go to times 10. And we'll have to re-zero the meter because this uses a different battery. Alright, there's times 10. Let's see what we've got. So we're looking at about 60 ohms. So something is shorted in there, or partially shorted. I'm going to place my money on it being one of those capacitors that I showed you. So we'll take the cover off. We'll get the chicken stick out and make sure the capacitors are discharged. And remember, these caps, if the conditions are dry, if the humidity's low, these caps can hold a charge for days. So you don't want to be sticking your fingers in there. So we'll take the cover off and discharge the caps and see if we can find the bad one. When I say caps, I mean the high voltage supply caps. Alright, in our schematic, these two capacitors are labeled C130 and C131. Those are the two that I showed you are in a series configuration with the center grounded. And good old MFJ, if I move the camera over here gently as I can, that's these two capacitors. Only on the board they're not C130 and C131, they are C30 and 31. However, I know it's the right capacitors. We have the black wire coming from the safety interlock, and underneath the white wire coming from the fuse goes to the other one. So I know those are the two. Oh, not very well in the view here, or in the frame. I know those are the right two capacitors, and interestingly, I put an ohm meter on them, and they both measure around 50 or 60 ohms. So I'm going to remove both of them. I won't bore you with watching me do that, and we'll see what they look like out of the unit. Oh, and by the way, over here we have our high voltage capacitors. Now I went in there with a chicken stick and a resistor and made sure that they were all discharged, checked them with a voltmeter, checked the voltmeter against the battery just to make sure the voltmeter was working, and then I went to one last thing and I shorted all the capacitors just to make absolutely sure I didn't get knocked on my tuchus. It's most unpleasant. I've been knocked on my tuchus before, and it leaves a lasting impression. Okay, we're going to pull these out and take a look at them. Well, it looks like Murphy has bit me in the tuchus again. I've got the two safety capacitors removed, and now that they're out of the circuit, I've tested them and they are both fine. And it is looking more and more like I have a partial short to ground in the primary, which seems very strange. But I still have my 60 ohms to ground across one leg of the transformer, so my next move is going to be to remove all of the jumpers that are in there that use for voltage selection, and isolate the two main primaries and isolate this small buck boost winding, or I guess maybe it's just a tickler winding, but I'm going to remove all the jumpers that were in this thing, and probably a good idea to change these anyway. They're not very well soldered in. I bought this used. And we'll find out if I have a leak to ground somewhere in the transformer. I am hoping I'm wrong, but we'll see where we get. It's the next logical step. It looks like the only thing left in the schematic is the primary of the transformer. We'll be back. Alright, let this be a lesson to you. This is how fast you can go from hero to zero. After disconnecting the primaries and checking them out, I was showing a short to ground, or a 60 ohm path to ground, on one of the primary windings. There's two 120 volt windings that go in series for 240 volts. And that's when I noticed that the fan was in parallel, and I'd seen this on the schematic but it hadn't registered. The fan, 120 volt fan, is in parallel with one of the primary windings, so that when you're running 220 volts it still sees 110 across one of the windings. Now, some time ago this had a modification with a temperature switch run over to a resistor so that the fan would run at half speed. If anyone's owned one of these amplifiers, you know how noisy the fan can be. It can drive you out of the room. And the fan runs at roughly half speed until the tube temperature starts to come up. The hot air being blown past the tube will trip the switch. And as long as you're careful, that's absolutely fine, as long as you don't go key down real heavy and heat the tube real quick. During sideband transmissions, the tube slowly comes up the temperature. This has plenty of time to kick in and compensate and keep the tube cool. In fact, during most transmissions, as long as you're not real long-winded, it won't even kick in the high speed. It stays nice and quiet. I've checked the temperature of the tube with a non-contact thermometer, and it stays well within safe limits on the anode. But what happened when I converted this over to 6 meters, there's a little tuning capacitor that comes through the back of the chassis here that I added. There's a little network inside so that the cathode's tuned properly, so that my transmitter sees a nice 50 ohm load and everybody's happy. Well, these wires were run between the sub chassis and the back panel, and when I added these two screws, I inadvertently pinched these wires very tightly against the back of the chassis. Now, I wasn't even aware that they were running down that deep. I thought they were right up here along the back edge. Over time, the insulation on these wires began to migrate, and there's a little place right here on the insulation. You probably can't see it. Doesn't matter. The insulation over time has migrated. Now, this amplifier has been in service for a couple of years, and it just so happened that the other day, oh, there it is, it's up far enough now, you can probably just make out the little pinch in the insulation right there. Over time, the insulation migrated from being compressed. Eventually, it short-circuited to ground, and there was my 60 ohms through the dropping resistor for the fan. So it just goes to show you, don't jump the gun. I shouldn't have pulled those capacitors out right away. I should have done a little more sniffing around. So we'll put a little bit of heat shrink on this, make sure the wires are routed correctly. We'll put everything back together, put the screws back in the back panel, and put the thing together, and hopefully it's fixed. See you in a few minutes. So, safety capacitors back in. All the wiring back on the primary of the transformer. The wires in the back here have been rerouted so they're not being pinched, and no chance of them being pinched. And far enough away from the high voltage we shouldn't have a problem. This is Teflon wire, so it's got real good insulation on it. Anyway, we've checked the plug with an ohm meter. No continuity of any kind to ground, so we'll throw the cover back on, put it back up on the shelf, plug it in, and we'll do a smoke test. And there we have it, up and running. The smoke did not leak out. That's a fortunate thing. We're running about 2500 volts on the DC for the anode. Right now my line voltage in the house has dropped to 230. The transformer's tapped for 240 because in the wintertime the voltage goes up to just about 240. Right now my 120 is running 115, and that's why my UPS keeps kicking in and out. I'm going to have to get in there and set the threshold a little bit lower. When the winter time comes around, the line voltage goes up to a solid 120. In the summer it's down around 115, which is a huge improvement, because before I had them put the new transformer in, it used to be 107 on a very good day and get down to about 90 volts in the summertime. It used to be miserable here. But anyway, we turn the power off and all the lights go out like they should. No more shorts to ground. We can see the voltage dropping off. Very good. We're ready to rock and roll. So another successful repair finally. I was wrong about what the problem was initially. That's twice in my life. I guess that's not too bad a record. Hi. Thanks for stopping by. Hope you found this enjoyable. If you did, please give us a like. A subscription would be appreciated. Take care. This is the Radio Mechanic. See you soon.